Hey guys, today we're going to take a look at composite functions and combinations of functions. Starting out with domain. If a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So if we are finding the domain of the function, it's anything that would make the value true. So in this instance, this equation is the equation of a parabola. So the domain of all parabolas, as we have talked about in the past, is negative infinity to positive infinity because they go on forever in the x direction. When you have a fraction, as an example b, you need to factor the denominator. And in order to factor the denominator, we say what multiplies to -3 and adds to -2. So what multiplies to c and adds to b. And in that case, it's -3 and 1. -3 times 1 is -3, and -3 plus 1 is -2. Now, we can never have 0 in the denominator, so x minus 3 cannot be equal to 0, and x plus 1 cannot be equal to 0, because 0 in the denominator of a function is undefined. So x cannot equal 3, and x cannot equal -1. Another way we could write that is the domain is negative infinity to -1, -1 to 3, and 3 to infinity. Finally, square root functions. Square root functions exist when whatever is under the radical is greater than or equal to 0, because we cannot take the square root of a negative number. So if we solve this inequality by subtracting 12 from both sides, we get 3x is greater than or equal to -12. Divide both sides by 3. X is greater than or equal to -4. So we can either write it like that or an interval notation, which is -4 to infinity, and that would be the domain. So here are my domains for these examples. Then we're going to look at compositions of functions, and we have sum, difference, product, quotient, and that's pretty straightforward. Literally, it's just combining like terms. When you have two functions, when you have f plus g of x, you add them together. 2x minus 1 plus x squared plus x minus 2. And you combine your like terms to get x squared plus 3x minus 3. When you are subtracting, just make sure, so f of x minus g of x, make sure that you put that in parentheses. That's a 2. So you distribute your minus sign. So you end up with -x squared plus x plus 1 by combining your like terms. F of x times g of x is just multiplying everything together. Actually, I'm going to come down here and do that. So 2x minus 1 times x squared plus x minus 2. So that is foiling to every term. So we get 2x cubed plus 2x squared minus 4x. Then we have to do it again with the 1. Minus x squared minus x plus 2. So our final answer is 2x cubed plus x squared minus 5x plus 2. And finally, division. You're just putting one on top of the other. But when we divide, it's important to state the domain because we have a restriction here. So if we were to factor this, the denominator, we would know that x cannot be equal to -2 or x cannot be equal to +1. So our domain would be from negative infinity to -2, -2 to 1, and 1 to infinity. So each little interval, as long as we are not including -2 and +1. All right, so in example 3, find each of the following. Literally, we're just going to add our terms together, and when we do that, f of x plus g of x, we have square root of x plus 3 plus square root of x minus 2. And that's our answer. We cannot combine our like terms. We cannot do anything else. Now, finding the domain of f plus g, we can look at everything individually. If we looked at this piece, x plus 3 would have to be greater than or equal to 0. So x would have to be greater than or equal to negative 3. If we looked at this piece, x minus 2 would have to be greater than or equal to 0, or x would have to be greater than or equal to 2. All right, so what does that look like? We could look at it as a number line. We've got negative 3, we've got negative 2, negative 1, and so forth. We know that f, the domain of f, has to be greater than or equal to negative 3. We know that the domain of g has to be greater than or equal to positive 2. So over here would be g. I'm going to go ahead and extend f. All right, so if we're looking at what f plus g could be, the only thing that they have in common is anything after 2. So our domain in total of the entire thing is 2, infinity. So it has to be what do they have in common. The next part is composite functions, and this you've seen before. It's read right here, f of g of x, or you could also say g of f of x, but it's when you're taking one function and substituting it into another function. So, important, the domain of the composite function is the set of all numbers such that x is in the domain of g, and g of x is in the domain of f, and we'll look at an example of what that means. So we have these two functions, f of x and g of x, and we want to find f of g of x. So that means I am literally going to take g of x, which is up here in green, and substitute it in the parentheses right here. And that means now I'm going to find f of this function. So I am going to take f and substitute in x squared minus 2x plus 6 minus 4. So I'm taking f and substituting that in for x. Distribute, you get 3x squared minus 6x plus 18 minus 4. My final answer is 3x squared minus 6x plus 14. Okay, now if we want to find g of f of x, we take g and we're going to put f of x in here, which is 3x minus 4, and now we are going to take this and plug it in for g. So we would have 3x minus 4 squared minus 2 times 3x minus 4 plus 6. Literally plugging this in for all the x's. So you have to FOIL this out, 3x minus 4 times 3x minus 4, distribute minus 6x plus 8 plus 6. So this is 9x squared minus 24x plus 16 minus 6x plus 8 plus 6, giving me a final answer of 9x squared minus 30x plus 30. Okay, and what does it mean when we have, I always like to rewrite this, g of f of 1. You always work inside out. So start by finding f of 1. F of 1 is just 3 times 1 minus 4, which is negative 1. So now I want g of negative 1. So negative 1 in parentheses squared minus 2 times negative 1 plus 6. is just 1 plus 2 plus 6, which is 9. All right, so we've got all that. And the very last thing we're going to do is look at the domain of what happens when we put them together. So in this case, we're going to find f of g of x. So f of 3 over x. So I'm going to have to do a little algebra here. I'm putting 3 over x in the function of f. And I get that, which is not super pretty. So I'm going to make a common denominator. 3 over x minus x over x. So then I get 2 over 3 minus x over x. And in order to get a fraction out of the denominator, I have to multiply by the reciprocal. So I'm going to multiply by x over 3 minus x. So I end up with 2x over 3 minus x. So that's my function. You need to clean that up so you don't have any fractions in the denominator. And now what we need to look at is what is the domain. The first thing that we need to know is because g of x equals 3 over x, 0 cannot be in the denominator. Because we can't have anything divided by 0. So 0 can't be in the denominator. The other thing we need to exclude, we've got 2 over x minus 1. So we must exclude from the domain any value for which g of x is equal to 1. Because this value right here, x cannot equal 1. So that means 3 over x cannot be 1. So x cannot be 3 if you cross multiply there. Just cross multiply. So x cannot be 3 and x cannot be 0. So our domain is negative infinity to 0, 0 to 3, and 3 to infinity. That might take a little minute to look at just to make sure that you can figure out what we got going on. The last thing is if I give you a composite function, meaning this is the cube root of x squared plus 1, what can I come up with for g of x and f of x to make this a true statement? So I kind of have one big cubic function, which is kind of the main part of this. Then I have the inside piece. So if I let f of g of x equal h of x, then f of x squared plus 1, I'm just taking that and plugging it into f, I end up with the cube root of x squared plus 1. So that's kind of the check. So this would be my answer into how would I break down the composition of two functions. And that's kind of how we do it. So that's going to take some playing with. Your homework is the worksheet on the back. Circled problems on the back of the worksheet. And just remember, anytime you have a division problem, state the domain. Anytime you divide, state the domain. All right, and we will go over this first thing the next class, but I think you're going to be good to go.